Yep.
رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. Bismillahirrahmanirrahim. Respected teacher and all my friends, Assalamu alaikum wa rahmatullahi wa barakatuh. Today, the motion of my lecture is green chemistry. So, first of all, let us define what is green chemistry. If you want, you can open your copies and write it. Green chemistry is the design of chemical processes and products that reduce or eliminate the use and production of hazardous substances. One thing that we must mention is that there is a difference between green chemistry and environmental chemistry. In green chemistry, we are trying to minimize or eliminate the production or use of hazardous substances. But these hazardous substances, when they go into the environment, they will affect the environment. And when they will affect the environment, that is included in environmental chemistry. But what we are talking about is how to minimize or reduce the effect of hazardous substances. How can we stop the production of hazardous substances? Now, before we go any further, we must remember some points at first. What is atom economy? Sai has already given us a lecture at the first. Atom economy, shall I write it? Atom economy equals to mass of product, the useful product, divided by the mass of total reactants. Mass of total reactants into 100%. In case of green chemistry, the more is the main product, the more is the atom economy. And if a process is has a higher atom economy, then it is green chemistry. According to green chemistry, it will be more fruitful. And we want to make the atom economy higher. So how can we do it? So to discuss that, we need to see the basic concepts of green chemistry. There are five main principles. As Bronzap already mentioned, 12 main points. I can just sum up those in 5 points that will come in handy. What are the 5 points? Number 1, changing to renewable resources. Number 2, finding alternatives to hazardous substances. Hazardous substances. Point number 3, developing new catalysts. Number 4, making more efficient use of energy. And the last one, but not the least, reducing waste and preventing pollution. And preventing pollution. Now let's explain. Point number 1, changing to renewable resources. Now, in the current situation, we can find that people all around the world are just fighting for finite resources like oil or natural gas or coal. They're just fighting for it. For example, one country is invading another country just for oil. But think it like this: why do we need to use renewable? Why do we need to use finite resources, non-renewable resources? We can easily go for renewable resources that will be sustainable. And if we use sustainable resources, then there will be no fight. There is no need of crude oil. You see, crude oil has some bad effects after we have used it, like carbon dioxide production and this and that. But if we use renewable resources, we will not have such kind of problems. So let's see in renewable resources some of the renewable products that were formed. For example, we can say PLA, polylactic acid. Let's not write it. Polylactic acid. What happens in polylactic acid? It's a green plastic. Like the usual traditional plastic, it is not like traditional practice. Traditional plastic, we find that that they are non-biodegradable. They are not degraded in the soil, and also after you have used, you can't recycle it. But what in case of PLA? In case of PLA, we find that it is also biodegradable and as well as it is recyclable. So if we use PLA instead of plastic, then it will not affect the environment. No hazardous substances will be produced. That's what green chemistry is all about. Now PLA, how is it produced? In PLA, it is produced from the raw material lactic acid. Lactic acid is produced by the use of bacteria which converts sugar into lactic acid. And this lactic acid, under the presence of a catalyst, under the presence of a certain catalyst, is pairs up to form cyclic compound. Then this cyclic compound, under the presence of another catalyst, forms polylactic acid. Okay, so polylactic acid is one of the examples of renewable resources we can use. Now, what about biofuel? Let's see, talk about biofuel. Usually, biofuel, we can say, how about wheat? Let's say wheat. We can produce biofuel from wheat. At first, what we have to do is we have to put wheat in a place, in a sealed container, so that no more oxygen can enter into it. And after we have done it, we have to heat the container. If we heat the container, as there is a certain amount of oxygen present inside it, the molecules of wheat will break down into smaller molecules, but it will not burn up. As it will not burn up, there will a certain fuel will be produced. That's what we call biofuel. Biofuel, on the other hand, is a renewable resource, and we don't have to just we will not have any problem with it. We will always have a supply of this biofuel. Then comes starch. Okay, let's say about starch. The starch, in the modern chemistry, we find that starch has given us a lot of products. You can just complete, I can just finish saying it. For example, you can see dye fixing, adhesives, then so many products. I mean, I'm just confused with the products. Okay, let's finish it. Okay, this is number 1. Done with number 1. This is number 2. Finding alternatives to hazardous substances. Let's talk about the product. It's called herbicide, that is called Roundup. There is a company named Monsanto. They produced this herbicide called Roundup. Now, what's the problem with this is that when Roundup is produced, there are some toxic chemicals given out of it, and that was a very problematic. That was very problematic. Then the Monsanto introduced a way where no toxic substances are needed. For the production of Roundup, you needed two toxic substances. One is called hydrogen cyanide, and the other is called methanol. Both are toxic substances, and there are a number of steps that you have to go through before you can produce Roundup. But as there are toxic substances used, there is a risk for the workers. And if there is any accident occurs, then the entire thing can burst up. Then the entire population, then the community will be in problem. So what they did, they changed this product. They used selective polonium as a catalyst, and they used solvent as ethanol. And when they produced Roundup, there was no problem and there was no toxic substances used in it. So it is a green chemically, it's a good product. Then comes supercritical carbon dioxide. Supercritical carbon dioxide is one of the most amazing things I have ever seen. If you can ever see, anyone can open the YouTube, just click, go there, search for supercritical carbon dioxide and just watch it. It's amazing. So what is supercritical carbon dioxide? Think of this as a cylinder. I give one side of a cylinder. Okay, you're seeing the face of the cylinder. There is a cylinder at that side. Here, they keep some carbon dioxide, liquid carbon dioxide. Now, when this thing is heated, the liquid carbon dioxide usually becomes gas. Okay, usually becomes gas. And this amount of liquid carbon dioxide goes down. So a certain time comes when there is no liquid carbon dioxide left in the container. What we are left with is liquid gas carbon dioxide. But the problem is, if you just shake the thing a bit, then you'll find a new color, a gas. Here you can't see anything, colorless. Then it will form a gray gas. What will it do? It will have all the properties of gas, but the density of liquid. Because here the volume, we know density equals to mass by volume. So mass by volume. So the volume is not changed here, and the mass is also constant. So what happens? All the gas against the density of liquid. So at this condition, we know that carbon dioxide is not poisonous, it's not toxic, so we can use it as a solvent. In the industries, most of the industries, we find that volatile organic compounds are used, as most of the organic solvents do not dissolve in water. That's why when we use this one, supercritical carbon dioxide, there is no toxic material in it, so it is economically better and green for the entire environment. Next comes Zoloft. This is another thing, amazing thing. They invented Zoloft. Let's come to the point 3, developing new catalyst. Now, in most of the processes, for example, there are some toxic waste substances produced there, and we don't want those toxic waste substances. So what can we do? If we can develop a new catalyst that will not require any toxic waste substance, it will directly convert the reactant into the desired product we want. Then we can eliminate the hazardous substances, and it will be economically greener and environmentally greener and economically more safe for us to use. And developing new catalysts, in this point you can, for example, say ethanoic acid. Ethanoic acid in around 1930s, when it was produced at first, ethanoic acid had an efficiency of only 35%. Only 35%. Atom economy, if something has 35% efficiency, it's not good for an industry. So after a while, the Monsanto, the same industry, they developed a new process. They used a cathode of rhodium and some other things to make the process go faster. But yes, the process was faster. The problem was that it was an exothermic reaction, and it was so powerful that they have to control the environment very hardly, and a lot of energy and a lot of materials were needed, and it was not safe. So later on, a new process was developed that was called, they used iridium as a catalyst. Now, iridium is much cheaper than rhodium. And iridium doesn't have any exothermic reaction. The reaction, iridium allowed the reaction to be endothermic. So we can control the environment very easily as it is not exothermic. And the process was very much faster and it was very good. Okay. Then comes making more efficient use of energy. How can we make efficient use of energy? Let's see. Catalyst, we all know about catalyst. What does catalyst do? It lowers down the activation energy needed for a reaction to occur. So, if we can use a catalyst and lower down the energy, activation energy needed for the reaction, then with less energy, we can produce more product. With less energy, we can produce more product. So, in this way, less energy is needed, and if less energy is needed, we'll have to produce less energy in the industry. So, less carbon dioxide will be released while producing the energy. So, in one way or the other, it will be eco-friendly and it will be more efficient in the world. Next is insulation. For example, you have made a very nice industry. In that industry, everything is going fine, but the pipes that take the solvents and this and that into and out of the container, it's not insulated. It just gives away the heat. So if the heat is given out, so we are losing the energy. If we are losing the energy, then our atom economy will go down. And if atom economy goes down, then the process is not efficient. So what can we use? We can use an insulator. If we cover up the entire pipe and machineries with insulators, then no heat will be lost. I mean, very less heat will be lost, and the process will be more and more efficient. And there is a new machine now used in many of the industries called heat exchanger. What they do, you see the waste gases that are given out, it has some temperature in it, it has some warmth in it. What it does, the heat exchanger takes away the heat from the waste gas and use it for the entire production, for production of electricity. In this way, it's very helpful. And there are many processes, for example, the production of iron, or many other processes where we find that production is, there are some exothermic processes. As exothermic processes give out some energy, we can use this energy for the need of the other processes in the reaction. We can see in the iron production process. So if we can do that, for example, there was a situation where the exothermic process gave out so much energy that the industry, they took those energy, produced electricity, they used electricity for their industry, they used for everything needed in the industry, and they had some surplus energy. They sold the electricity to the national grid. Rather than taking electricity from the power supply, they are giving electricity to the national grid. How amazing is that? Then comes recycling. If you want to make a process, make it more efficient, then recycle it. How can we do that? For example, you have glass and metal and this and that. After you have used it, after you have used a mobile, after it's just wasted, you can't use it anymore. What do? You throw it in a dustbin. But if we don't throw it in a dustbin, but rather in a recycle bin where it can be recycled, then what will happen? That old glass can be used, can be processed again, and a new glass can be formed, right? So if a new glass is formed from there, it doesn't have to be, all the processes needed for glass procuration and to make the glass is not needed. Less processes are needed for the recycling, so less energy is needed for the recycling. If less energy is needed, it is more energy efficient. That's the way it is. Then we can use in this one, for example, let's say, an oxidation process. We see if we give air and heat the air for oxidation, there are total 16% oxygen in the air, other 84% other gases. We don't need those gases. But what happens? We also heat those gases. So 84% of the gases are not needed to be heated. So the efficiency of the entire oxidation process is only 16%. That's too low. So what can we do? No need to heat nitrogen, no need to heat other gases. Let's just heat oxygen. How can we do that? We can use pure oxygen. If we use pure oxygen, then oxidation process will be 100% efficient. I mean, some will go out, but still around 100% efficient. And last but not the least, microwave. In industries nowadays, in pharmaceutical industries, microwave is widely used. What is the use of microwave? In pharmaceutical industries, there are some reactions that if you just do it in a regular oven, it will take some nights for the reaction to occur. In a regular oven, some nights for the reaction to occur. So what do? They don't use regular oven, they use microwave oven. So what happens there? The microwave goes inside the material and it vibrates the polarized material. As a result, the entire material is vibrates quickly. As a result, it is heated much faster than the ordinary process we use. As a result, nowadays in pharmaceutical industries, a reaction that would take some nights are now done in just a minute. The reaction of some nights are done in just a minute. How fast has microwave made our processes? Now, at last, reducing waste and preventing pollution. Now, there is a group called Lilly Research Laboratories. They invented a drug. I mean, that drug, for each 100 kg of that drug, 300 kg of waste chromium is produced, 35,000 liters of solvents are needed for this reaction. For each 100 kg of product, this much is wasted. It's just not logical, but they used it. But later on, they invented a process. They are not saying how they did it. Okay, never mind. So that shows that no need of this, no need of this. They can directly produce 100 kg of 100 kg of the drug without the need of this, using green chemistry processes. Okay, that's it. And there are also for reducing waste, we can use alternate processes. Like I said, recycling or this and that. If we use recycling or some other processes like that, then we will not have waste. If we don't have, we have less waste, then we have to take care of less waste. So less energy will be needed, less cost will be given here, and it will be more economically helpful. Now, suppose we have some waste. What will we do with the waste? We can't use it anyways. Some waste like that. What will we do? What we can do is incineration, combustion process, or we can just bury it deep into the ground. In incineration process or combustion process, if we burn it, we will get some energy for it, but carbon dioxide will be produced, and that's very harmful for the environment. And also, if it's not heated properly, then dioxin, it's a material, it will be produced as well. It's very toxic for the environment and not good at all. So this is not good for the environment. So it will be a very troublesome problem for us, and we couldn't find any solution yet for the problem. And for example, if you want to bury in the land, for the problem is we have shortage of land. People need land, this and that. You don't have such lands all over the place. So this is the problem as well. So what is the best way? If we can use the waste and recycle it. For example, okay, let's just say we have the waste. Let me ask you a question. What is the best way of getting rid of the waste? Any answer? What is the best way of getting rid of the waste?
Using waste which do not produce that much waste or harmful waste.
Okay, one.
Prevention.
Sorry?
Use it for any useful purposes.
Okay, same thing. Any other? The best way to get rid of waste is not to produce waste at all. That's the best way. So, okay. So these are the main points. Now, if we can follow these main steps and develop new greener processes, the green chemistry is still a child in this sector of chemistry. They're still a child. We have a lot of work to do. We have a lot of waste to take care of. And now it's time for us to make the green chemistry a better thing. It's time for us to develop green chemistry. So, can we use green chemistry for a better tomorrow? Yes, we can. Yes, we will, because we must. Because if we don't, you won't see it tomorrow, inshallah.
One question. Can I
Yes,
ask
sir.
a question?
Yes.
But I can't understand the
Yeah.
link between the supercritical carbon dioxide and green chemistry.
Supercritical carbon, yes sir. Supercritical carbon dioxide, if you see in some industries, they use toxic solvents, volatile toxic solvents, okay,
Okay,
organic
okay.
compounds. So if you, that's poisonous, that's not good. So if we use supercritical carbon dioxide, it's not toxic. Any more
Good.
question? Any more question? Anyone?
Any question?
Any? Okay, thank you.
Very
Assalamu
good.
alaikum.